Okay, in this video I'm going to review with you how to use the crisscross method. You've gone through your slideshow and you probably have gotten up to slide number 19, and I've told you to check out this video. The crisscross method starts with the ions written separately, and their charges are in the upper right hand corners like I've drawn here. The crisscross method says crisscross, bring them down, drop the charge, and then simplify. So I'm going to bring down the -2, but I'm not going to bring the charge with it. I'm just going to bring down the 2. I'm going to bring down the +1, but I'm not going to bring down the charge with it. I'm going to drop it. And then simplify. You don't need to write a subscript of 1. All you need to do is write the element symbol once. So the finished product would be Na2O. Now let's do another example. Here I have magnesium, a +2 ion, and oxygen, again, a -2. If I crisscross, remember I'm going to drop the charge, so I'm only bringing down the 2. And over here I'm only bringing down the 2. I would end up getting Mg2O2. So I did crisscross, bring them down, I dropped the charge. Now the last step, as I said before, is to simplify. So instead of writing Mg2O2, I want to write this in its empirical form. In other words, when I look at these subscripts, they're both divisible by 2. I can reduce the ratio from 2 to 2 down to 1 to 1. And this is the correct formula. If I wrote Mg2O2, it's not empirical. I have to reduce it to its simplest whole number ratio, 1 to 1. Let's do a few more examples. Let's take aluminum, a +3 ion. And let's combine that with oxygen. Crisscross, bring them down, drop the charge, and simplify. Easy. 2 and 3 are not both divisible by the same number, so it's already in its empirical form. It's already in the simplest small whole number ratio. So this is correct. Now let's talk about polyatomic ions. A polyatomic ion is a group of atoms that acts as a single ion. So when I look at reference table E, the formula for the polyatomic ions is given to me. I can't change those formulas because the name tied to them is fixed. Let me show you what I mean. If I have calcium and I want to bond it with nitrate, the formula for nitrate is NO3. The charge on nitrate is -1. This whole entire group is one ion. So when I do the crisscross, the 1 applies to that ion, the 2 applies to everything, the whole ion. It doesn't change any of the subscripts in here. So when I write the formula, I'm going to get calcium, 1, and I'm going to get 2 nitrates. So I'm going to write nitrate inside parentheses, and the 2 out here tells me it applies to the whole entire ion. So the ratio is 1 calcium to 2 nitrates. This ratio cannot be further reduced, so this formula is empirical. It's written correctly as it is. Let's do some more practice with some more polyatomic ions. Let's take a group 1, sodium, and sulfate. Remember, the -2 applies to the whole polyatomic ion. So this 1 tells me I need 1 sulfate for 2 sodiums. So 2 sodiums, 1 sulfate. I don't need the parentheses when I only have 1 polyatomic ion. So I didn't have to surround it by parentheses. The formula was correct when I simply wrote it as Na2SO4. That means 1 sulfate. It's 2 to 1 is the ratio. Let's do a little bit more practice. Let's take a transition metal like iron. Now iron can have a +2 or a +3 charge. In this case I'm going to use iron +2, and let's combine it with sulfur. What do you get when you do crisscross? Well, I'm going to bring down the 2, bring down the 2. I'm going to get Fe2S2, and then I'm going to simplify it, and I'm going to get FeS. Now let's try a polyatomic ion with iron 2. Remember, that whole polyatomic ion, that charge applies to the whole thing. So when I bring this 2 down, I have to bring it outside those parentheses. 1 iron, 2 nitrates. I want you to continue practicing in class using the crisscross method. And one final example, what if we had 2 polyatomics? Very few polyatomics have a positive charge, but ammonium is one of them, NH4 + 1. And let's say we did carbonate. Well, I would have 1 carbonate to 2 ammonium. So I would write NH4 parentheses 2, and I only need 1 carbonate, so I don't need parentheses. When there's only 1 polyatomic ion, you don't need to surround it with parentheses. I want you to continue practicing examples in the classroom, and come see me if you need some help. That's all for now.